Unit 10A, normal distribution. Given a raw score, find an associated area. The heights of pea plants are normally distributed with mean 20 inches and standard deviation 4 inches. What percent of the plants are shorter than 15 inches in height? Let's make a picture of the information. We have a normal distribution, a bell-shaped curve. Mu is 20, that's the mean, goes in the center. Standard deviation is 4 inches. And we want to know what percent are shorter than 15 inches. Well, 15 inches would be below 20 somewhere. So let's say this is 15 inches. And we want the percent. Percent we should associate with area. We want the area shorter than 15. That means the area below 15. We're looking for this area. What is that area? So we want to find this area. We could use the calculator, the TI-84. We press second, distribution, and then choose number 2, normal CDF. And depending on the calculator, if you have a menu, what you have to include is for the interval we're talking about, where we want the area, we have to have the endpoints. So this endpoint is 15, that's the high point or the upper endpoint. The lower endpoint, there is no lower endpoint. So pick a very low number, pick a very small number, at least 5 standard deviations out from the mean. So I'm going to use -999 just to ensure I'm way out there. So we're going to have to input this low end, this high end of the interval, mu and sigma. So there they are, inputted into the calculator. Then we click on paste, and the answer should appear. 0.1056. So 0.1056 would be this area, or if you want to write it as a percent, 10.56%. We can do the problem using the normal distribution table. We're looking for an area. Now the table associates areas with z-scores, not raw scores. So if we're going to get an area, we need to get the z-score. To do that, we'll have to change the raw score to a z-score. So the first step is change 15 to a z-score. The formula is z equals x minus mu over sigma. X is 15 minus mu is 20 over sigma is 4. So that says z equals -5 over 4, or -1.25. Now we can change the z-score to an area using the table. Using the table, we know that z is -1.25. So we go down the z column until we see -1.2. Then across the top, for the next digit, 5. Where this row meets this column, That's the area below the z-score, 0.1056. So this area is 0.1056. We can check our answer in the following way. If we take our distribution, we know sigma was 4. So if we start at mu and go over 1 standard deviation would be 24, and 2 would be 28, and so on. Going the other way would be 16, 12, and 8. If you remember the empirical rule, this area is 34, this is about 13.5, this is 2, and this is very small. So we're looking for the area below 15. So where is 15? 15 is about here. So we want to know, what's the area below 15? Well, it's going to be a very small amount here. That's negligible. Here we have 2% plus this area right here. Now, the entire area from 12 to 16 is 13.5%. So we don't have that. We have a number less than 13.5. So we have to estimate, what is this area right here? Well, I don't know, maybe 4 or 5, or something like that. So if we subtract that, let's call it 4. If this area is 4 from 13.5 is something like 9.5, so we get 11.5%. Well, if you recall, our answer was 10.56%. That's about 11%. This is 11 or 12%, so it's our answer sounds reasonable. So 10.56% of the peat plants are shorter than 15 inches. End of Unit 10A. See Unit 10B for normal distribution. Given an area, find the corresponding raw score.